Almost done with chapter 10. This is video 6 for chapter 10. So here we're going to be talking about samples and populations. Our targets say we can identify what samples and populations are and determine when a sample is a good sample, right? When it's representative of the population that you're looking at. So we're going to talk about the vocab words biased and unbiased and what those mean. And then also using data from samples to make predictions about a population, right? So this goes back to setting up proportions again to solve problems. So fill in your targets. All right, our vocab. So population is an entire group or people of, an entire group of people or things, right? So all of the residents of Heartland, all of the students of War Creek, all of the fish in the pond. All right, a sample would be just a small group or just a part of that population. So maybe you talk to just 7th graders. That would be a sample of the students here at Orr Creek. Or you talk to, or you pick just 25 fish out of the pond to look at. That would be an example of a sample, just part of that whole group. And then random, we've already discussed random, is all things or all outcomes or all different objects equally likely to be chosen. Okay, so we know random. We've used that word in everyday life. So then thinking about a sample, we want our samples to be unbiased. I know it sounds a little backwards, but unbiased is good. We need unbiased samples. Okay, so in order to get a good unbiased sample, there are 3 things we need to have. 3 traits of a good sample. Number 1, it has to be big enough, right? It's not a good sample if you only pick 3 fish from the pond, or if you only talk to 2 students at Orr Creek. That's not going to be a good enough, large enough sample to give you enough data. Number 2, it has to be random, so all the students equally likely to be picked, or any of the fish equally likely to be selected out of the pond. And then number 3, it has to represent the whole population. Okay, so we can't just talk to 7A students if we want to know something about the whole school. Or you can't just pick the biggest bass in the pond if you want to know something about all the fish. Okay, so we're going to keep these things in mind as we go through these examples. And then biased, okay, biased is bad. So if you have a biased sample, then it does not meet one of these conditions. Okay? A biased sample might be where you only pick your favorite friends to talk to, or you only pick, a certain part of a certain group within your population. All right, so we don't want biased samples. We also need to know what valid means. So if we're making conclusions about a population, we want our conclusions to be valid. We need them to be accurate, right? Correct, reasonable. The math has to work out. We have to be using good samples. So we want valid conclusions. An invalid conclusion would mean it's not accurate, not correct, not reasonable, not based on a good sample. Okay? All right, so we're going to look at identifying a population, right? Picking what population you want to look at or research or find out about. Then picking your sample. Then you're going to gather some data from your sample and use that to make interpretations about the population. And then you have an inference, or you learn something about the population because you looked at a sample. And if your sample is good, right, if you have a good unbiased sample, then you learn good information about the population. Because you probably can't talk to every student, or you can't look at every fish in the pond, so we use samples to learn something about the population. Okay, so here you have 5 choices, and I want you to think about each of these 5 choices and pick the best sample, okay? So, let's say you wanted to find out what the favorite elective class is of all the students at Orr Creek Middle School. And you don't have time to talk to everybody, so which of these would make the best sample? So read through them for a second. Okay, let's see. If you only talk to art students, that would be a biased sample. You're not talking to everybody in the school. 13 friends in band class. Again, they're probably going to be biased. That's just from one group of different elective classes. If you only talk to 7th graders, okay, that's not talking to 8th graders, so you're not including them in your sample. 4 random 7th graders and 4 random 8th graders. We're getting better, right? Now we're random. We're talking to everybody, 7th graders and 8th graders. But our best sample here would be E, right? It's random. It's large enough, right? 50 names out of the school is better than just 8 names or 5 names. And it's from the whole student roster, so everybody's equally likely to be picked. So it's random, large enough, and representative of the whole school. How about this one? You want to know whether Heartland citizens approve of a new stoplight at M59 and Old 23. Okay, well, your population is Heartland citizens. So as you read through these choices, you need to make sure that you're looking at all Heartland citizens. Okay, so take a minute to read the choices and pick the best one. Okay, just Meijer employees, probably not looking at all citizens equally likely to be selected here. Just bus drivers, that's only one select group, so it's not unbiased. If you're looking at driver's license numbers in all of Livingston County, well, that doesn't fit with the population we want to look at. We just want Heartland. Your 5 closest neighbors, probably not a good, big enough sample. 100 names picked from the Heartland phone book. If we had a Heartland phone book, that would be your best sample, right? Random, large enough, everybody equally likely to be picked. Okay, read through these ones real quick and pick the best one. Again, notice that your population is Michigan residents, so we need it to be large enough, random, and representative of the entire state. So just going through it quickly, we can't talk to just Heartland, we can't talk to just teachers, we can't talk to people in Florida because that doesn't match the population we're looking at. 5 is not a big enough group. 10 random people from every county. Yeah, right? It's large enough, random, and equally representative, right, of the whole state. Okay, so now let's think about if these conclusions would be valid. All right, if you want to, right, thinking about that new stop sign, if your population that you want to know something about is just the neighborhood residents, and you ask 4 people in line at Meijer, I want you to circle, would you be able to make a valid conclusion? Or would any conclusion you draw from that be invalid, and why? Okay, so go ahead and do A and B here, and then we'll talk about those. So pause here and do A and B. Okay, for A, I would say this is invalid, right? Number 1, 4 isn't enough people, and you don't know that those people in line at Meijer are actually the residents that you're trying to learn something about. Right? So your sample probably doesn't represent your population. B, you want to know about a ban on texting while driving. Your population is Michigan residents. 200 random residents from the state. Yeah, I'd say that's valid, right? It's large enough, and you should be writing this down on the line for why. It's large enough, it's random, and it represents your population that you're trying to learn about. C, you want to know if Heartland citizens want to require uniforms at school. All right, so your sample is 100 8th graders. Circle valid or invalid. Would any conclusion you make from talking to these 100 8th graders be a good conclusion? Well, no, right? If you're only talking to 8th graders, that doesn't represent your Heartland citizens. So it might be random, it might be large enough, but it doesn't give you a whole range of people from all of the Heartland citizens. How about, do you want to know if Brighton residents want to build a new power plant? And you talk to 1,000 county residents. Random. Well, that sounds like enough people. Sounds random, that's good. But if you talk to county residents, you're looking at people other than Brighton. Okay, so you have to also make sure it represents your population. Invalid. E, You want to know if Heartland families want to build a new football stadium. Okay, so you talk to fans at the game on Friday night. Well, maybe you have enough people. Maybe it's random. But again, people who are at the game are going to be biased. It's not going to represent all of your Heartland families. Okay, maybe these are just people who, have students at Heartland High School or people who love football, right? So invalid there. So we're going to talk more about samples and populations, but we have to understand what makes a good sample and whether our conclusions would be good. All right, so now we're going to be using proportions to solve questions here. This says you ask 75 random students how many movies they watch each week. There are 1,200 students in the school. Predict how many watch one movie a week. Well, all right, looking at our results here. One movie a week is this section here. So 21 out of the 75 people you talk to. And I'm going to label these so I can line up my proportion. And then I want to know out of the 1,200 students, well, that's a total, so it would go here. How many is that who watch one movie a week? And cross multiply. Right, I don't see an easy arrow here, so I'm going to cross multiply. And when I cross multiply, I get that. So we've done lots of proportions all throughout the year, so I'm not going to review that, but we should be able to set up and then solve our proportions here. All right, according to your survey, 75% of Oak Creek students plan on going to college. Okay, this is just a reminder that we can write our percents, 75 out of 100 if it's a percent. So there's my first ratio in my proportion. 705 students plan to go. I'll say college. How many students are there at Oak Creek? So again, pause here, cross multiply. Let's make sure we get the same answer. I got 940 total students. So really this is just about reading it carefully, setting up and labeling your proportion. And then, all right, here's question C. So you're going to need this chart. And then the question asks you 50, right? So this adds up to 50 students that you talk to. You ask them their favorite sport. If there are 600 students in this school, how many do you think like soccer the best? All right, so try this one, pause, work out your proportion, and then hit play when you're ready to check. So I had my proportion here for soccer, total, and I was looking for how many would like soccer. I found an easy arrow here. You could also cross multiply, but I got 144. And here's D. You ask 120 random people at the stadium what their favorite food is. If there are 50,000 people, how many people would like nachos? All right, so go ahead, last one here. Set it up, pause, and then we'll check. Okay, so 24 out of 120, and that came out to 10,000 out of 50,000 people at the stadium. So that's our video going over samples and populations.